With this code, you can get data from Arduino to Matlab just only with one channel. So basically, you put your sensor in the analog pin number 1. I initialize a variable I with 0 and I initialize another variable called sample at 20. This variable here set our sampling frequency. So I did several tests, and the best sampling frequency to set in Arduino is 20. I will show you, I will explain you later why. So basically here you just write the normal code for get input from an Arduino, and here you print the value that you read from the channel where you attached the sensor, and you put it as I, which is your your integer variable here that you set at the beginning. Then you print it and you put the delay as our variable sample, so, which is 20. Why this delay? Because I did several tests, as I told you before, and this kind of optimal sample rate for Arduino in order to get the data from Arduino to Matlab. Then the Matlab code will be something like that. So this is the Matlab code. Basically, first you have to declare an Arduino object which contains the information of the USB port where you connected Arduino. You can find the USB port in Arduino Tools port, okay, and the sampling of the serial port should be 9.600. Here there's a try and catch code where we basically open the port where Arduino is connected, but if the port is not open, this code just displays this message here. Okay. Then we set the total time of data collection, which is 10 seconds, the sampling time, which is 0.01, that corresponds to 100 Hz, an index value of 0, a matrix called data, and a time variable called t. We start a while loop. Before a while loop, we start the tick-tock code where we put the tick before the while and the tock inside the while. Inside the while loop, we increase the index one by one each while loop, and we fill the matrix data with what we scan from Arduino. So this fscanf get the data from Arduino, from the USB port where Arduino is connected. And the code here just forces the sampling rate. If Matlab is reading faster than the sampling rate of Arduino, it forces the sampling rate to be the one that is set in Matlab. If Matlab is sampling the data slower than Arduino, you can do nothing. So basically this code here forces the sampling rate set to Matlab if it's faster than the sampling rate set in Arduino. And then you close the port. Remember to close the port, because if you don't close it, you cannot write anything into Arduino again. So you cannot use Arduino codes anymore. If you want to get data from two analog pins, this is the code. So you have to initialize two analog pin 1 and 2 here as integer, two variable ing set at 0, and as usual sampling rate of 20. So here in the pin mode you add the second input, okay, and also in the void loop you add the second input. So the variable g will have the value of the analog read A2. Now this is the important part. So you have to write serial print, and the first input, the first variable related to the input of the channel A1. Then you print a t, which is a space between the two values, and you add a serial print ln with the variable g. It's important that this should be serial print ln and not serial print. Otherwise, Matlab will not read this data, okay? We'll read just the data coming from the first value. So this is the code that you have to do and that you have to use if you want to use two inputs. Then the Matlab code is pretty similar of the previous one, except that the data has two columns here with two values 0 and 0, and in fscan you add another d here in the parentheses. Then you fill the data matrix, the first column of the data matrix, with the raw data in the first position and the second column of the data matrix with the raw data in the second position. This refers to the channel number 1 and number 2 in our Arduino code. And then here we force Matlab to the sampling rate declared here at the beginning if it is faster than the sampling rate of Arduino. Otherwise, it will go slower. Raw data contains the data that Matlab read from Arduino in two columns. So raw data has two columns with the first one is the column related to the sensor number 1 and the second one the column related to the sensor number 2. So remember that, because if you change something here or if you change something in the Arduino code, it might be that the data would not be in column but would be in row, and in that case this code doesn't work. So follow the code that I give you in Arduino and this code to get the data for each column. If you want to add some column, you just have to add them from the Arduino code first and then add them here.